rational equations. So, start with the approach. First thing we'll do is factor all the numerators and denominators. And then we'll identify any unacceptable values. These values will be values that make the denominator 0. We will then eliminate denominators by multiplying through by a common multiple of the denominators, preferably the least common multiple. And then we will solve the resulting equation, comparing the results with the unacceptable answers. So let's look at this example. Here we have 7 over x minus 4 minus 2 equals x. First thing we want to do is factor all the numerators and the denominators. Okay, so here we don't really have anything we could factor. We do need to know that the 2 is over 1 and the x is over 1. Because essentially what we want to wind up doing here is we're going to want to find a common denominator in this third step so that we can kind of do some elimination. But before we get there, we need to identify any unacceptable values. The unacceptable value in this one would come when we are dividing by 0, which could happen in this first part of the equation where I have a division by x minus 4. So I need to know that x minus 4 cannot be equal to 0, which means that x cannot be equal to 4. That's one of my unacceptable values here. Okay, now I need to try my best to eliminate these denominators. Now if I look at my denominators, I have an x minus 4, a 1, and a 1. So my LCM of the denominator here is x minus 4. So what I want to do is I want to multiply this entire equation times x minus 4 to get rid of the denominators. Okay, what this looks like, I'll write the entire thing out. This will be x minus 4 times 7 over x minus 4 minus 2 times x minus 4 equals x times x minus 4. So I've multiplied everything by x minus 4. What that does, if you see that first piece, what that does is allow the x minus 4 to cancel out in the first piece. Now we don't have any denominators to worry about. Now we can solve this resulting equation and simplify. So I'm going to go ahead and start simplifying. I have 7 minus 2x plus 8, because all I did was distribute the 2 here, or the negative 2 in this case. And then I'll go ahead and distribute the x, equals x squared, and then x times negative 4 will be minus 4x. Now I need to get everything all on one side. I'm going to wind up taking everything to the right hand side. Before I do that, I'm going to go ahead and simplify a little bit more on the left hand side. 7 plus 8 will give me 15. So the left hand side will simplify down to negative 2x plus 15 equals x squared minus 4x. And like I said, I'll carry everything over here to the other side. I'll add the 2x over and I'll subtract the 15 over. So add the 2x, subtract the 15. And here's what I get. I get 0 equals x squared minus 2x, because negative 4x plus 2x is negative 2x, minus 15. Now I can factor this into two terms. I can factor it into an x minus 5 and an x plus 3. Okay, which means that x minus 5 has to equal 0, or x plus 3 has to equal 0, which will help give me my two solutions. One of my solutions is x equals 5. My other solution is x equals negative 3. I then need to compare these results, the results I just got, the x equals 5 and the x equals negative 3, to my unacceptable answers. My only unacceptable answer here was x cannot be 4. So I don't have any overlap here. So indeed my answers are x equals 5 and x equals negative 3. Now let's try another one. So example 2, to solve this equation. Here I have x squared over x minus 1 equals 1 over x minus 1. I want to factor all numerators and denominators. Here everything's factored. Don't have anything I need to really worry about. Then I need to identify my unacceptable values. Well, on both pieces here I have an x minus 1 in the denominator. So it would be unacceptable for x minus 1 to equal 0 in this case. So it can't equal 0 in this case, which means that x cannot be equal to 1. That is my only unacceptable value here. Now, following what we would do is we would multiply by our least common multiple, okay, of the denominator. In this case, that's x minus 1. So what I'm really doing is multiplying everything times x minus 1. So it'll be x minus 1 times x squared over x minus 1 equals x minus 1 times 1 over x minus 1. I think you can already see what happens here. The x minus 1's cancel, and I just have x squared equals 1. Okay, now I can solve that resulting equation. If I take the square root of both sides, I get x equals plus or minus the square root of 1, which is just x equals plus or minus 1. But now I need to compare that with the unacceptable answers. We have an unacceptable answer here where x cannot be equal to 1. Unfortunately, x equal to 1 was one of our posted solutions, right? Because it could be either a positive 1 or a negative 1. So what this means is the only valid answer for this one winds up being x equals 1. X equals negative 1. X equals 1 is no longer a valid answer because it's unacceptable because it would cause a division by 0. So we have to mark that solution out. Now let's go on to the next one. All right, let's click to the next one. All right, example 3. Now, I don't have the whole solution part written out. We're going to follow the same kind of outline. We're going to factor the numerator and denominators, identify any unacceptable values, eliminate the denominators by multiplying by the LCM, and then solve the resulting equation, and then check any of the unacceptable values. Okay, so step 1, factor all numerators and denominators. Now here, if we look at this, I have 2 over 3y plus 3 minus 5 over y squared minus 1 equals 6 over y minus 1. Now, I can't factor any of the numerators here, but I can factor some of the denominators. Matter of fact, I can factor the first 2 denominators. The last denominator is as factored as it can go. So let's factor this first denominator. I'm going to keep the numerator the same. What can I factor out of 3y plus 3? Well, I can factor a 3 out. If I factor a 3 out, that leaves me with a y plus 1. Okay, well, that's the first one. Now, I'm going to rewrite the numerator in the second one. What can I factor y squared minus 1 into? Well, I should be able to factor y squared minus 1 into y plus 1 times y minus 1. All right. Now, like I said, the last one here is already as simple as it can be and as factored as it can be. But what you notice here is instead of multiplying everything, if we would have just multiplied by all the denominators, we would have had to wind up multiplying by 3y plus 3 times y squared minus 1 times y minus 1, and that wouldn't have been the LCM in this case. The LCM in this case is actually, I know I'm skipping a piece, but the LCM in this case will actually wind up being 3y plus 1, y minus 1. Okay, which is significantly simpler than multiplying by everything in the denominator. But before we get there, and before we do that distribution, let's go ahead and identify any unacceptable values. Now, I have a y plus 1 in the denominator and a y minus 1 in the denominator that could cause some issues. And this is going to let us know that y plus 1 cannot equal 0 and y minus 1 cannot equal 0. I'm not really worried about the 3 right there. If you did 3y plus 1, or 3 times y plus 1, or if you did the 3y plus 3 equals 0, what you would find is you get the same solution as the y plus 1. But if I solve both of these out here, I see that y cannot equal negative 1 is one of my unacceptable solutions, and y cannot equal 1 is my other unacceptable solution. All right, now let's get back to solving. So if I do this distribution, I'm going to write the entire thing out, so bear with me. It's going to be 3 times y plus 1, y minus 1, times 2, all over 3 times y plus 1, minus 3 times y plus 1 times y minus 1, times 5, all over y plus 1, y minus 1, equals 3 times y plus 1 times y minus 1 times 6 all over y minus 1. Okay, now we get to do our handy dandy cancellations here. All right, let's do some cancellation. Cancel it out with the orange. Okay, the y plus 1 cancels with the y plus 1 here, and the 3 also cancels. That's nice. The y plus 1 cancels here and here. The y minus 1 cancels here and here. Okay, and then the y minus 1 cancels here. Now I don't have anything in the denominator, and I can just go about my simplification and solve steps. Okay, well, let's do that. Now, here we're going to have a y minus 1 times 2 minus 3 times 5. 3 disappeared. Equals 3 times y plus 1 times 6. Now let's do some simplification here. I'm going to have to distribute the 2 here to the y. So it'll be 2y minus 2. 3 times 5 is 15, so it'll be minus 15. Equals, distribute the 3 to the y and the 1. And I get 3y plus 3. And I also need to multiply that times 6. Okay, you could have multiplied by the 6 first. That would have probably made more sense. Let's do that. You could stick with the train that we just started if you wanted to. There's many ways to simplify this. But what I'm going to go ahead and do is combine the 3 and the 6 to give me an 18. And then I'm going to distribute the 18 to the y and the 1. Just to save us a step and some space. If you need to do multiple steps, that's fine. So it'll be 18y plus 18. Oof. My marker keeps jumping on me. Okay. Now, I can simplify a little bit more on the left-hand side here. I'm going to get 2y minus 17 equals 18y plus 18. Now, I need to get my y's together and my whole numbers together. So I'm going to subtract 2y over to the right-hand side, and then I'm going to subtract 18 over to the left-hand side. So this should give me, that's negative 35 equals 16y. And then we divide by 16 to get y by itself. And we get that y equals negative 35 sixteenths. All right, we found a solution here. Now we have to be certain to compare that solution to our unacceptable solutions. So if I compare y equals negative 35 over 16 to our unacceptable solutions, those are y equals negative 1 and y equals positive 1. That's what can't happen. Those are unacceptable. Our solution isn't equal to any of our unacceptable solutions, so it is indeed our solution, and this is the answer. Y equals negative 35 over 16. All right, let's go on to the next one. All right, the next one here, I have 6 over x plus 1 plus 2 over x equals 5x minus 3 over x squared minus 1. All right, same thing here. We're going to factor anything that can be factored. Okay. The first one can't be factored. It's just a 6 over x plus 1. The second one also cannot be factored. It's just a 2 over x. The numerator and the last one cannot be factored. It's a 5x minus 3. But the denominator here, the x squared minus 1, can be factored into an x plus 1 and an x minus 1. Okay. So we've done that. Now, let's look at any unacceptable solutions. Okay, now if I look at my denominators here, I see that x plus 1 cannot be equal to 0, x cannot be equal to 0, and x minus 1 cannot be equal to 0, which lets me know that x cannot be equal to negative 1, x cannot be equal to 0, and that x cannot be equal to 1. Those are our three unacceptable solutions. Okay. All right. So now that we've gotten past that, we need to multiply by the least common multiple of the denominator. If I look at the denominator here, I have an x plus 1 and an x. This one has an x plus 1 and an x minus 1, which means that my least common multiple that I'm going to multiply by here should be, I'll go ahead and do it up here, should be x times x plus 1 times x minus 1. That should be my LCM of the denominator that I'm multiplying by to get rid of all of my denominator. So let's go about doing it. Okay, I'm going to write the whole thing out. We're going to do x times x plus 1 times x minus 1 times 6 all over x plus 1. And then we're going to do x times x plus 1 times x minus 1 times 2 all over x. And then we're going to do x times x plus 1 times x minus 1 times 5x minus 3 all over x plus 1 times x minus 1. Okay, now let's look and see if we have any cancellations that occur here. We ought to. The x plus 1 cancels with this x plus 1. The x cancels with this x. And the x plus 1 cancels here. And the x minus 1 cancels here. So let's work on simplifying. Okay, I'm going to work through this simplification step. Here I have x times x minus 1 times 6 plus x plus 1 times x minus 1 times 2 equals x times 5x minus 3. Okay, let's see what kind of simplification we can do now. All right, here, to me, it's going to help me if I move this 6 in front of the x here. Okay, now watch what I do. I'll move that 6 in front of the x. That allows me to go ahead and distribute 6x to the x here and the 1 here. Okay, so that's going to give me 6x squared minus 6x. Okay, now here, I think what I'm going to do is leave the 2 alone for now. So I'm going to leave it out front. And I'm going to go ahead and FOIL out the x plus 1 times the x minus 1. Now if I do this, I get x squared. And if you do x and x is x squared, x times negative 1 and positive 1 times x cancel each other out. And I get 1 times negative 1 is negative 1. Okay. I'm going to go ahead and distribute the x on this side. It's going to give me 5x squared minus 3x. And now the only thing I really need to do, I'm going to come over here and do it. It's going to have, I'm going to leave the 6x squared alone, minus 6, I'm going to leave it alone. But I'm going to go ahead and distribute the 2 to the x squared and to the negative 1 now. So it's going to be plus 2x squared minus 2 equals 5x squared minus 3x. Okay. Now I should be able to combine some stuff, right? And then we're eventually going to move everything all to one side as well. But let's go ahead and see what we can combine on this left-hand side to simplify a bit. And then we'll move the stuff on the right-hand side over to the left-hand side. So I can combine the 6x and the 2x, the 6x squared and the 2x squared. That's going to give me an 8x squared. I can't combine anything with the negative 6 yet on the x. And I can't combine anything with the negative 2 yet on that side. So this is where I'm at. But what I'm going to do now is I'm going to subtract the 5x squared over and add the 3x over. So I'm going to subtract the 5x squared over and I'm going to add the 3x over. And what this is going to give me is 3x squared minus 3x minus 2 equals 0. Okay. Now, if you can factor this, hats off to you. I'm going to put it in the quadratic equation at this point. So, I'll write that out for you. I'm going to do negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay. This is going to give me negative 3 plus or minus the square root of b squared, so negative 3 squared, minus 4 times a, which is 3, times c, which is negative 2, all over 2 times a, which is 3. Okay. Now this is going to give us a positive 3 out front, plus or minus. Now, if I look at 3 squared, I'm going to change colors here because I don't have but so much space left on the slide. Negative 3 squared here is a 9. Negative 4 times 3 is negative 12. Negative 12 times negative 2 is positive 24. Okay. So on the inside, what I'm really looking at here is the square root of 9 plus 24, which is 33. And then 2 times 3 is 6. Oops. Now, you can't simplify that any. You can't break the 33 up into anything that'll simplify as far as square roots go. So those are your two answers. One of your answer is 3 plus the square root of 33 over 6. And I'll write it out for you. You can split it into 2 if you want to. It'll be 3 plus, oops, still trying to write the plus or minus here. Would be 3 plus the square root of 33 over 3. And the other solution would be 3 minus the square root of 33 over 3. Now, if we compare those to our unacceptable solutions, neither of those align with any of our unacceptable solutions. Therefore, they are our answers. I prefer to just write it like this, but if it makes you split it into 2, you can split it into 2 just like that. Now let's go on to example 5. Example 5 is 3w over w plus 2 over, or plus 6 over w equals 12 divided by w squared plus 2w. Okay. Now, following the same frame of events, what I want to do is go ahead and factor, if possible. Now, I can't factor the first term. The first term is 3w in the numerator and w plus 2 in the denominator. Neither of those are factorable. The second term of 6 over w, also not factorable. But that last term, the 12 over w squared plus 2w, that is actually factorable. Because I can pull out a w. If I pull out a w, I'm left with a w plus 2. So this last term here actually factors into a 12 over w times w plus 2, which is convenient because it's going to give us a little bit better LCM for the denominator to multiply by. But before we do that, let's look at our unacceptable solutions. Okay, our unacceptable solutions are anything that's going to make our denominator 0 in this case. So here we can't have w plus 2 being 0, but we also can't have w being 0, which means that w cannot equal -2, and w can also not equal 0. Those are our unacceptable solutions we have to be aware of. All right, now let's move on to solving. We need to multiply by the LCM of the denominator here. That winds up being w times w plus 2, because I have a w plus 2 here, a w here, and then I have a w times w plus 2 in the other solution. So let's do that. We are going to do w times w plus 2 times 3w all over w plus 2 plus w times w plus 2 times 6 all over w equals w times w plus 2 times 12 all over w times w plus 2. All right. Now, let's look at our cancellation here. And this one, the w plus 2 cancels. And this one, the w cancels. And in this one, the w and the w plus 2 cancels. All right, let's see what that gives us. Well, that gives us a w times a 3w. That gives us a w plus 2 times a 6. And on the right-hand side, it just leaves us with a 12. Okay, well, that's fine. Let's see what happens next. Well, here, I wind up having a 3w squared. If I distribute the 6 to both the 2 and the w here, I wind up with plus 6w plus 12. Okay, that equals 12. All right. Now, what if I subtract 12 over to the left-hand side? Well, if I do that, that's going to give me a 3w squared plus 6w equals 0. Well, what if I pull out, what can I pull out of 3w squared and 6w if I wanted to? Well, I could pull out a 3w. If I did that, I'd be left with a 2w. Sorry. Nope, I'd be left with a, sorry. Oops. What would I be left with? See if you can fix my little writing error there. If I pulled out a 3w, I'd be left with a w plus 2, not a 2w. And that would equal 0. So I just factored a 3w out. Now what that gives us here is that either 3w has to be 0 or w plus 2 has to be 0. And if I divide by 3 here, I see that that gives us the solution of w equals 0. And if I subtract 2 here, this gives us the solution that w has to be -2. But wait a minute. The solutions that I wound up with after solving are both unacceptable solutions. So what does that mean? Well, if the only solutions that I'm able to come up with that'll work for this equation are also unacceptable solutions, that means that overall, I have no solutions. So, if we're looking at the different cases that we could possibly have here, we could have scenarios where we have a single solution, multiple solutions, or even no solutions. All right, well, that completes this particular chapter. Go on and try your homework. If you have any questions, don't hesitate to reach out to me by email. Be glad to help you. And I will be back to see y'all for the next lecture.